Hi students, this is Dr. Kavita from SNS College of Technology. In this session, I am going to explain about the interaction to beam in the engineering mechanics subject. So first we have to recall some topics before getting into this topic. The first you should know that what are the basics laws which are used in the engineering mechanics. For an example, you have studied the Newton's first law, second law, third law, parallelogram law and Lami's theorem, everything in unit 1. And similarly equilibrium of forces. If you are if you are solving any beams, the problems in the beams, you should know that equilibrium of forces. You should know that equilibrium condition. So the equilibrium conditions of summation of vertical force, summation of horizontal force and summation of moment, it is equal to 0, and we are finding the unknowns. And also you should know that the center of gravity and the centroid, and the moment and the couples. The moment is the nothing but product of force into perpendicular distance, and types of structures. The types of structures are framed structure and load bearing structures. Mostly we are using the beams in the framed structure, and the different types of properties of the material. So for an example, Young's modulus, rigidity modulus, etc. And what are the different types of loads and effects on the structures. So now we will see that the topics we are going to see in this session is what is a beam and what are the types of beams, and what are the loads which are acting on a beam, and what is the how where we are using the beams in real life, and primary functions, and also the support reactions, everything we are going to see here. So first you should know that what is a beam. So if you are taking this beams, we are using in mainly we are using in the RCC structure. That is a framed structure. That structure may be a building, or may be a bridges or floor joists, anything. So you can see this. This is a reinforced concrete framed structure, and it is made up of slab, beam, column, and foundation. So if you are taking the framed structure, the load transferring mechanism is mainly by from first the slab load will be distributed to the adjacent beams. Okay, if you are taking the slab, the types of slabs are one-way slab and two-way slab, and you will study these detailedly in next year. Here the some part of the load from the slab will be distributed to the uniformly distributed to the beam, this beam. Again, if you are taking this beam, this will carry the slab load from this part. So similarly, the loads will be transferred to the adjacent slabs, that's by this manner. And first we have to see what are the types of beams. Here if you are seeing that according to the supports, we are classifying the beams as cantilever, simply supported, overhanging, continuous, fixed, and cantilever, simply supported. So the first these 5 things are very important. If you are taking the cantilever, you can see this. So this color shows that the supports, and the blue color shows the beam. Here if you are taking the beam, there are 2 ends are there. The one end is fixed and another end is free. So here we are calling this beam as cantilever, and here you can see this, both the ends are supported, one side by hinge and another side by the roller. And here 2 supports are there, but beyond the support some portion of the beam is overhanging, therefore it is nothing but a overhanging beam. And here you can see that the supports are more than 2. Whenever the number of supports are more than 2, we are calling that as a continuous beam. And here you can see this, the 2 ends of the beams are fixed. Okay, it is a fixed beam, and you can see this is a cantilever, and here the one end is fixed and another end is supported by the roller. We are calling that as the proper cantilever, or cantilever simply supported. So here we have to understand where we are using these beams in real life structures. So here you can see this, whenever we are using in a beam in a bridge, we are calling that as a girder. So here the girders are supported by the piers. Okay, so this type of support we are calling it as simply supported beam. And here you can see this. This is a some auditorium. For there is a football ground, you can see this, the one end is fixed, the another end is free. So mostly we are using these types of supports in the porticos. And here the beams are, you can see this, there are, it is a continuous beam, but here the ends are fixed. So therefore we are calling that as a fixed beam. And if you are getting into the overhanging beam, here this is a girder, and beyond the girder the beam is projected. So this some portion is overhanging, and therefore we are calling that as this beam as a overhanging beam. And here you can see this, the beams are supported by more than 2 supports. It is a continuous beam. And we will see that different types of load, point load, UDL, UVL, etc. So first we will see this point load. Here you can see this is a beam and the column is there. This column will create the point load on this beam. So I have given so many examples here for point load. And the next one is some masonry, brick masonry work is constructed above the beam. This will create the uniformly distributed load on the beam. And if I am explaining about the UVL, so this is a beam, and here the roof slab, that is the sloped roof, is constructed above the beam. This will create the triangular load. We are calling this load as a uniformly distributed load, since it is the load is distributed uniformly from the one end to the another end. So here what are the primary functions of the beam? So if I am taking the primary function, it should support the slab and the loads should be transferred to the adjacent columns. So that is the main thing. And here you can see this is a reinforcement what we are providing here. This is a main reinforcement and this is the stirrups. So we are calling this as a longitudinal reinforcement or main reinforcement, and the vertical lines shows the stirrups. That is a shear reinforcement. So the main reinforcement will be taken care for the bending moment, and the shear force will be taken care by the stirrups. So I think from this session you have understanding what is the beam and what are the types of beam, what are the loads which are acting on the beam. So thank you for listening this video. Thank you.